Today we're going to discuss things around blockchain and digital assets and lots of things happening in this industry where the possibilities of tomorrow are endless. The world is rapidly changing, transforming to digital currencies and assets, and understanding the complex infrastructure of blockchain and Web3 is no longer a luxury. It's actually a necessity. The mainstream adoption of digital assets face significant challenges from security concerns to scalability issues, and the path forward is fraught with obstacles that need innovative solutions. So in today's episode, we'll be in discussion with Dr. Duncan Wong to explore the cutting-edge solutions and advancements in distributed ledger technology. We'll look at the complexities of integrating blockchain into everyday business, the evolution of privacy and security in digital transactions, and the future trajectory of digital currencies. Dr. Duncan Wong is pioneering work as a founding member of the Quantum Safe privacy-preserving cryptocurrency project Abelian. Additionally, he's the CEO of CryptoBlock, a Hong Kong-based company at the forefront of DLT solutions tackling enterprise challenges. So with his rich background leading with the 10 fintech initiatives at Hong Kong's largest R&D center, Astri, a notable academic career as a professor and a prolific author in cryptography and information security, Dr. Wong brings unparalleled insights into the future of digital assets and blockchain technology. So welcome to the show, Dr. Duncan Wong.
Thanks, Albert. Thanks for having me.
Yes, of course. No. Happy to have you here. So I would love to hear first about your background into the space. It's always interesting how many people got into blockchain, cryptography. Can you share your journey into your academic work into Abelian and CryptoBlock?
Yeah, sure. So my background is basically engineering, electrical and electronic engineering. I grew up in Hong Kong and then I went to the States for my PhD. So while I was doing my PhD, I basically did my research in cryptography. And that's basically related to blockchain because cryptography is the fundamental of blockchain, all that digital signature, hash function, and all that. So after I got my PhD, I came back to Hong Kong being a professor, kind of like a usual path, a career path for somebody who got a PhD in computer science or cryptography in Hong Kong. So I spent more than 10 years being a professor doing research in cryptography. And that's when the Satoshi Nakamoto's white paper was out. And then I was teaching courses related to blockchain. And that actually amazed me regarding this fully decentralized digital asset stuff. So, and then I spent some time to really study about the blockchain stuff and also decided to basically take a sabbatical from the university and work for Astri. Astri is a R&D center in Hong Kong, the biggest R&D center in Hong Kong, being funded by the government. And I spent 3 years there. Actually, that changed my life. I decided instead of spending time at university doing research, writing papers, supervising PhD students, I decided to really start working on my own projects. And that's how I began the CryptoBlock back to 2017, and then started working on Abelian back to 2018. And Abelian is a post-quantum blockchain which can make use of the post-quantum cryptographic technologies, and that's the basically the turning point for myself instead of just writing papers, but actually implementing products. And that's how I began working on this Abelian project.
How do you feel the government or the Hong Kong is actually forming the foundation for the future of future students to learn things around like blockchain and cryptography?
Yeah, so in fact, before coming back to Hong Kong, I've also been working at the Bay Area in the Silicon Valley for a while. So comparing with the Hong Kong situation, I think it's quite different. In Hong Kong, it's more focusing on the academic result, on the more theoretical things rather than practical stuffs, I have to say. So in the States, I got a lot of opportunities to really so-called get our hands dirty by building stuffs, by building products, by building systems, and also got a lot of financial support from the industry to build real products. And they would basically try out those real products. But in Hong Kong, to be honest, we are really lacking of this opportunity. Down the road, I really hope that there will be more opportunity through the collaboration between Hong Kong and mainland China, especially the Greater Bay Area. I hope that the situation can be better, especially what I'm noticing is that the government is actually introducing more opportunity to big corporates in mainland China to come over to Hong Kong. That basically give a good so-called buffer for young people to join some of the big companies to learn and then to come out and spin up some of the startups. That's basically my wish. But at this moment, to be honest, the Hong Kong students, they are really lacking of opportunities to try it out or to build stuffs. And that's basically kind of like a disadvantage. But as a practitioner in the industry, I've also been working hard to contribute to this to the industry by arranging hackathons, for example, arranging different events, just like Arthur yourself, right? You are also participating in this WOW Summit, and to have more activities in town would definitely bring more interest and more opportunities to the young people in Hong Kong.
Yeah, I can see that too. Yeah, so the WOW Summit is actually happening the 26th and 27th of March. And I think one of the things that we looked at, because I helped put together an agenda, there's a lot of narratives, I believe, that people would love to talk about. The interesting thing to see, since I've been in this digital asset crypto space for the past 8+ years, is a lot of attention is usually put on companies that are developing things maybe that can fit some of these narratives that are attractive to an investor. I always see like this very big separation between you either start your company and you're just trying to get fundraising for it, and who knows what will happen with that company or what type of products we will build, compared to the people who are really trying to use the technology and build layer 1, layer 2 solutions or something in the space to really solve a problem, right? To really, like you said, like what you've done is just go out there and build in a trial and area and really kind of disrupt, sort of like what's going on out there by testing. So I guess, I guess we'll see how Hong Kong shapes up.
I think in terms of in the industry, we all need to contribute our own aspects. And if the government can facilitate more to us by like introducing sandboxes to us, and also to provide some opportunity for us to collaborate with other jurisdiction or other regions, that would definitely be very helpful to us.
I think that's very necessary. If Hong Kong wants to be, right now it's seen as the potential hub for digital assets in the future. Obviously, Dubai is doing a lot of work to grow its ecosystem as well. But I think the whole point is in this distributed or decentralized type concept of technologies and businesses itself, is that we all need to share the knowledge, right? If we're going to work together in a big way, in a global manner, then I think we can definitely move forward much faster and understand the different intricacies between, let's say, even digital assets moving from one jurisdiction to another jurisdiction and how that's managed. Okay, so I'm on your site, and you're saying it's a post-quantum layer 1 blockchain. And I wanted to have you explain that, because I think a lot of people, I guess in technology or the audience, may not understand what is post-quantum computing.
Sure, yeah. So conventionally, what we are currently using, the so-called conventional computers, we call them Turing machines, Alan Turing, right? Like the very famous computer scientist Alan Turing during the World War II, he proposed a model which can basically formalize all the computers that we are currently using, from the desktop machine to supercomputer. They are all Turing machines. By using Turing machines, we will not be able to break some of the hard mathematical problems. For example, the encryption algorithms that we are currently using. Say, for example, like Bitcoin, Ethereum, they are using elliptic curve crypto systems. So elliptic curve crypto systems are believed to be secure against Turing machines, against our conventional computers. But quantum computers are quite different. Quantum computers, they work differently, that each bit, we usually call that the qubit, can represent both 0 and 1. So it's basically impossible for our conventional computer to have one single bit to represent both 0 or 1, right? But quantum computer can represent 0 and 1, and which basically give us a very powerful computational advantage by computing something in parallel. And quantum computer can basically break elliptic curve cryptography, which means if the quantum computer become mature, then we can use quantum computers to break Bitcoin or Ethereum by reversing every single wallet, so the hacker will be able to get your private key. That basically require a very powerful quantum computer. As today, we are not there yet. Like last year, IBM announced a quantum computer which had 1,000 qubits. 1,000 qubit, you can do some simple math in a very efficient way, but you will not be able to use that to break elliptic curve cryptography. You will not be able to break Bitcoin. However, the number of qubits basically doubles every year or every other year. It's kind of like following the Moore's law. Like every 18 months, there will be doubled the number of qubits that people can build a quantum computer. So if you have, for example, like 100,000 qubits quantum computer, then you can easily break Bitcoin or Ethereum. When would that happen? Nobody knows. Maybe 5 years, maybe 10 years from now. But the problem is that we need to upgrade our blockchain technologies well before this day comes. And this day is usually referred to Q date. Q stands for quantum, obviously. So for example, like as hackers, what hackers can do right now is that hackers can download all the public keys of those wallets, for example, from Bitcoin or Ethereum. And then they can just wait for, say, 5 years from now. Then they can use the quantum computer to reverse those wallet public key into private keys. And then they can own every single wallet on Bitcoin or Ethereum. So that's why well before the Q day, we need to do the upgrade. And this is the reason why we would like to build this Abelian chain, is to make that so-called future ready. So Abelian is basically we make use of some cryptographic algorithms which are secure against a quantum computer. So we don't need to worry about like 5 years from now, a 100,000 qubit computer is out and your blockchain will become insecure. So Abelian make use of those cryptographic algorithms that we use. We call it the lattice-based cryptographic algorithms to make sure quantum computers will not be able to break that. So this is basically the vision, our objective of building Abelian.
So if you're looking at today's industry and what people are building on the blockchain, can you give some perspective of why people are looking more into quantum computing, or is it the talent is not able to understand how to manage quantum computing? Is it very costly to kind of create processing power for this type of work? Yeah.
So in fact, if you look into the quantum crypto systems, quantum safe crypto systems, actually a lot of companies are already working on this. So let me just talk about the high picture, the overall picture first before zooming into blockchain. So for example, like Google, they previously, I remember like 6 months ago, they already announced that by using the Google Chrome, they have already included or embedded the quantum safe crypto systems into Google Chrome. So basically, if you have a server and the web server, and then that web server has, for example, lattice-based crypto system there, then you can use your Google Chrome to connect to that web server securely using a post-quantum cryptography. I remember like Signal also recently announced that they support post-quantum or quantum safe end-to-end encryption channel. So actually a lot of major companies and industry pioneers, they are already working on this quantum safe systems. Even, for example, like I said earlier, I mentioned about IBM, right? They are building this, and they are also building post-quantum crypto systems. So about blockchain systems, we are actually seeing more and more technologists or developers. They are actually moving into this post-quantum area. Even, for example, like Vitalik, he has been talking about making Ethereum post-quantum for years, for
Right.
at least 3 to 4 years. And even recently, he said this could be a priority for Ethereum, in addition to those features that he would like to see on Ethereum. Say some other chains, they are also working towards this. So, but the problem right now, what I'm seeing is that for most of the chains, because they are already making use of elliptic curve crypto system, and they need to do this kind of upgrade. And to do this kind of upgrade is not as obvious as just a simple hard fork. But basically, it's actually needs to start from the design stage to see whether if you replace the elliptic curve crypto system with, say, a quantum safe crypto system, whether you may break some other parts in terms of the security aspect. So that's why what I'm seeing is that actually in the academic, in the research industry, I mean the community, a lot of people, they are already proposing solutions to upgrade existing blockchain systems. And we are kind of like one of the first live network, which is already quantum resistant. So what I'm seeing is that in the coming 2 to 3 years, there will be more and more quantum resistant blockchain technologies or systems coming out.
Got it. Got it. Okay. So what does this mean to, I guess, blockchains in itself, where, let's say, Ethereum, obviously the gas fees extremely high. Everyone's looking at speed of transaction and how many you can process, and
Mm-hmm.
until everyone's trying to break that that challenge of speed and cost. With quantum, I guess, privacy preserving blockchain, is it what's the speed like? Does it have any significant impact to the overall performance of managing transactions?
Yeah, that's a very good question. In fact, the quantum crypto systems will make the scalability get worse, actually. The main problem is that let me just give you some numbers. For example, like elliptic curve crypto systems, the public key is 32 bytes or 64 bytes. That's it. Way less than 100 bytes. But for quantum resistant public key, we are talking about 1,000 bytes. So just imagine like the size. And also talking about the digital signature size. For the quantum safe, we are talking about 3 kilobytes per signature. But for a elliptic curve, we are only talking about like 128 bytes or even just 64 bytes. That's it.
Right.
So the scalability basically will get hurt quite significantly. This actually goes back to the infamous blockchain trilemma, right? We talk about scalability, security, and decentralization, right?
Yeah.
So my point about tackling this trilemma is that we need to think about like multi-layer, just like the internet protocol, like the stacking mechanism. So for example, like Abelian at this moment is a layer 1. We focus on decentralization as well as security, obviously, but we are not focusing on the scalability. So for Abelian, the number of transactions per second is actually pretty bad. It's only 20 transactions per second. It's even worse than the Ethereum. But we are building layer 2. So the layer 2 is going to be 500 transactions per second. So what we are doing over here is that we focus on the decentralization and security on layer 1. So for the decentralization, we even stick to the POW, the proof of work. And also we even stick to ASIC resistant, which means by making use of GPU cards to mine rather than using ASIC chips to mine Abelian, in order to make sure it's as decentralized as possible. Everybody, whatever you have a GPU card, then basically you can spin up your GPU card and start mining and contributing to the decentralization of Abelian. While at the same time, the security, we are making sure it's quantum safe. But in terms of the scalability part, we built the layer 2, and then we use a post-quantum zero-knowledge rollup to make sure most of the smart contract transactions are carried out on layer 2, just like Ethereum ecosystem, that most of the transactions, as you see nowadays, they are all on layer 2. And then there will be just a message digest, or we call it a witness, being recorded onto the Ethereum chain. So basically, Ethereum is the layer 1, which only stores the digest, but all the activities are actually carried out on the layer 2. So yeah, that's my pick. Layer 1 as the security decentralization, layer 2 for the scalability. And also I'm actually foreseeing that there will be multiple blockchain systems around the world, and we can make use of the bridging technology to connect all those blockchain systems together. Yeah.
Okay. Yeah, I know that quantum computing for sure uses more computing power, I guess, demands. And as you can, if you follow the GPU market, players like NVIDIA, recently microcomputing, the stocks have skyrocketed this past quarter. It's some amazing times, and I think it's not going to stop as well. I guess there's even server farms trying to manage things to use hydroelectric or geothermal power for these huge computational demands, right? For all these large language models and even quantum computing. So maybe you could explain a little bit more in your view. If we're looking at the space itself, we know that Hong Kong wants to come look at the stable coins or digital currencies or CDBCs. They're looking at how to manage new digital assets. They've got their virtual asset service provider licenses in place, yet, it's still got to go process that if you want to release, let's say, a product or a token, if you want to call it, to market, you still got to go through what seems to be very traditional, I guess, review cycles, like when you for any financial product. How do you see the your work for Abelian to create and support security? Because that's one of the main things, stopping financial crime and managing protection to the retail investors. So how does your work kind of impact that?
Yeah. So from the technologist perspective, I'm considering myself as a technologist. I'm trying to provide as many useful tools as possible to the community. So for example, like Abelian, my mission is to offer this kind of quantum resistant technologies to the world. We open source our code. We publish all our algorithms in order to make sure everybody can benefit from it. But basically, everything is kind of like double-edged swords. So on one aspect, definitely we can improve the security measures. We don't need to worry about hackers who process that kind of quantum computer and do bad things by stealing our digital assets from our wallet. This is one aspect. But at the same time, we do have this kind of like quantum resistant zero knowledge proof systems to improve the KYC as well, right? So for example, like on Abelian, we intentionally designed a system which provides privacy preserving to users, which basically means that if, say, Alpha, you want to transfer some tokens to me, say ABLES, our native token to me, you can transfer it in a way that the whole thing is totally encrypted. Nobody will be able to find out how many ABLES that you transfer to me. And nobody can even find out your sending wallet address or my wallet address as a receiver. But at the same time, we are providing a tracking tag. So we can basically share that tracking tag to an authority. So the authority will be able to find out who's behind each wallet address and also how many ABLES that you are transferring to me. So we are providing some of this. So this is just one of the examples that we are trying to provide different tools to to law enforcement and also to the users, so that the users can enhance their privacy, while at the same time, we will still be able to satisfy some of the compliance requirements. So I think the usability, the privacy, as well as the compliance, not contradicting to each other. As a technologist, I would like to build stuffs so that it can actually help both sides, because the compliance thing is really for protecting the interests of users, right? That's the fundamental purpose of having this kind of compliance of the legal. So it's not necessarily to be on the opposite sides. So that's why this is basically the approach that we are trying to do. Even, for example, like we have this quantum resistant blockchain layer, and we open source it so that people can actually just make use of our open chain. And then right now we are also building a bridge. So if you already have, say, for example, an application running on Ethereum, then I hope that in the very near future, we can make use of this Abelian bridge to upgrade your smart contract to quantum resistant as well. So you don't need to worry about the quantum attack in the future. You can just focus on your Solidity development to build your smart contract apps, and Abelian will take care of the quantum resistant part for other chains.
Wow,
so that's the dream. Yeah, that's the roadmap basically that we are currently working on. Yeah.
Right. Okay. So do you see any, so as a technologist, are you looking at any other things to help improve, I guess, what your solutions would be, whether it be AI, and then, working with other partners as well to kind of come up with solutions?
Yeah, so we are actively looking for partners to work together. Maybe speaking of the AI part, we are already making use of AI to do some security review on our code. I consider the blockchain technology and AI technology as kind of like parallel technologies that we can help each other. So, for example, we make use of those GPT models to get that trained about reviewing blockchain codes, and then making use of that trained model to look into our systems to see whether there is any loophole or any kinds of pitfall in our code. This is one area. Another area we are also actively looking into is about as I mentioned, we are a POW network because of for the decentralization. We also want the POW to be more meaningful. For example, like instead of just crunching the hash function to find a result, what if we make use of those GPU computational power to do some AI modeling training as the POW work? So we are actually investigating some of the AI training models and see whether we can dispatch those AI training models to our miners. They are not just doing the hash, but actually they are really helping the AI modeling while they are earning AVOs. Yeah. So these are just two of the examples that we are exploring and we are currently using AI. And definitely we can make use of the AI to do some more things. For example, like even looking into our architecture to see how decentralization we can be, and whether the AI model will be able to suggest some other ways for us to further decentralize our system as well.
Okay. Well, you'll be speaking at the WoW Summit this coming March, and there's be other people there, other companies, potential partnerships. Is there any people, or what would be the profile of an ideal partner that you would like to connect with?
I think at this moment, what we are trying to do is to really educate the public regarding this quantum resistant technology. So the key challenge for us is that we would like to bring Abelian, the quantum resistant technology, to as many people as possible. And one of the approaches is to reach out to some of the, for example, wallet developers or some companies that they have digital asset wallets or custodian services. So definitely I'm looking forward to working together with some of those wallet companies or companies that they have their own wallets or they are interested in getting into this field. I think this is one of the entry points for the general public to the blockchain technologies, by having this kind of different kinds of wallet holding digital assets. So I think it would be great for people to consider quantum resistant digital asset, for example, like Able as digital gold. And that's why we basically like market our Billion as digital gold 2.0, because it's kind of like Bitcoin, while at the same time it's quantum resistant. So that's why I think one of the groups that I'm looking into will be those wallet companies, other companies that they are at the retail market.
Okay. So I guess mainly companies that are creating solutions, hardware or software made to protect digital assets. Pretty much custodians
Exactly.
and wallets. Yeah. Okay. All right. So
Yeah.
I guess you mentioned with AI using that to kind of look at your code and I guess do its own self audit to identify any opportunities for, like you said, further decentralization. You know, I talked to a lot of builders who, at some point, they have a need, let's say, to validate their product on a compliant level, and they need to go out and, let's say, get audited by some company. But I hear these stories;
Mm-hmm.
it's very crazy, like $40,000 for looking at a couple of smart contracts, or I guess based on a monthly retainer fee and or project based, and it's quite expensive. How do you look at that space? Because when you're looking at, as a technologist, are you going through different checks and balances to also get your work audited as well by certain agencies?
Yeah, I think this is a very important part of the software development process, especially for blockchain technology, is to have multiple third-party security audit. In fact, for Billion, we also engage third-party security audits, and we are engaging multiple security audits to review our code. So the AI part is basically a preliminary work. Speaking of that, I have to say the AI way to do the security audit is still at the very preliminary stage. It's not very mature yet, to be honest. So right now, the AI approach is like you have a huge pool of vulnerable codes that you make use of those pool of vulnerable codes to train the AI model. And then the AI model will be able to identify something that the AI model has seen before, right? So the AI model will not be innovative to predict some other vulnerable issues that the AI model has never seen before. So we will not be able to just rely on the AI model to make sure our system or smart contract and all that will be safe, especially for a Billion. It's a layer one infrastructure. If there is a security issue, that can be disaster. So that's why we have to rely on, luckily or unluckily, human brain to really look into the code, and also being innovative enough to try out different ways to hack our system. So you are right. We spend a lot on the security audit. Yeah, and also we have our internal cybersecurity experts to regularly look into our codes. We have new patches or new versions coming out almost every other day at this moment. So our in-house cybersecurity team is very crucial for us to do the first round of screening, and they are actively making use of AI model to help them to make their life easier, to reduce the repetitive work. But in terms of the innovative work on how to come up with some more interesting attacks against the systems, that actually still rely on the human brain to do that.
Okay. Well, I want to pivot a little bit to what you had just mentioned, that, AI will only, it's an early stage, right? It's a very early stage of how it could help you, and it's still reliant on human brain. I follow this one podcast with this one guy called Raul Paul, and he always talks about the future of tech and how AI is going to really change things faster than people realize, where people will lose their jobs and, who knows what the workforce will look like in 5 to 7 years. As a technologist, what do you think about AI and what changes do you really see and how fast will they happen?
I think in the near term, AI can do the best is to reduce our repetitive work. That's the near term, like for the coming 5 years. Definitely, we can use AI as an assistant. But down the road, I think AI can be very innovative. Just like, for example, the cybersecurity audit review example that we talk about. In fact, if we can fit in the cybersecurity, the human cybersecurity audit process to the AI model, the AI will be able to learn how human would innovate, will find out new security issues. And if the AI model can look into more and more this kind of methodologies, the AI model will still be able to come up with some more innovative method to find new or unseen security issues. So I think down the road, I really think that the AI can be even more innovative than us. Just like we have been seeing some of those paintings, right, created by AI. They are even more innovative than human in some of the aspects. So I think that's going to be the future. And what's left to human in the future is really about some of the things, maybe the emotional part. I think the emotional part is not. Sometimes I would not say it's logical. And just like the recent movie, I don't remember the name of the recent movie talking about the emotional, that the AI can learn about the emotional stuff and all that. I still think that the emotional part is something that it's really hard to model unless human being will be able to really grasp the science behind emotion rather than
Right.
just consider that as a art. Yeah.
Well, yeah, I can imagine things that are emotion, like psychology, things like this, to really tap into the brains of people and how it really works. It's pretty deep. If AI can maybe crack some of it, I can see that, right? Because there's a lot of use cases already that it can learn from. Certain behaviors that are common behaviors of people based on certain triggers that happen in life. They can all go into this database to kind of help someone. And then I guess anyone, instead of you go to a psychologist and say, hey, this is my problem. I'm trying to figure out what's causing me to be stuck in life, or, whatever the issue may be. AI can probably get you so far, but it's still quite complex. I don't know.
Yeah. And also, I think people say that, well, if AI can learn about the emotion, AI is just faking it, right? Like AI has no emotion, and AI is just learning that emotion and try to, as you mentioned, like help us on the therapy aspect. That definitely would be very useful.
Yeah.
But what I'm thinking is that how we define about emotion and how this kind of like emotion would infer to some of the actions, and would AI be able to model that in the future? That can be very challenging from the technology perspective. Yeah.
Yeah. Okay. Well, going back on or staying on the lines of technology, you mentioned right now your focus on security and decentralization, and there's a large number of companies out there trying to create this solution around scalability. Some of them seem very short-lived, with like, kind of processing done on private chains, and people, very good marketers will, build a nice story for a company, but they're not there yet. I mean, what do you think about, as a technologist, what type of solutions are really viable to kind of solve around scalability? Like what needs to be changed, or what needs to be innovated?
I think the scalability improvement is incremental at this moment. We don't have a revolutionary approach. What I mean by incremental is that, as we can see, what we are trying to do is we cannot solve the trilemma, so that's why we built the layer 2. And then by making use of the layer 2 and also the zero knowledge proof systems or the zero knowledge proof technology to improve it, while at the same time we can also do the segregation of the network, right? As we can see, some of the networks, they are trying to divide the entire network into small segments, and then they can do the confirmation on small segments first. So basically, they are using the hierarchical or the layered approach to do that. I consider all this as incremental. In fact, we are also doing that. We will not reinvent the what we are still lacking, I think, in terms of the scalability, while at the same time being decentralized, is some kinds of revolutionary approach that we haven't seen one yet. I've been actively looking into the research academia to see whether there is any way to do that. A lot of the cases that people basically reduce the whole thing into centralization. I mean, they sacrifice the centralization while improving the scalability. We have seen some of the chains, right, that they are actually very centralized. While at the same time they can achieve like super great performance result in terms of the scalability. So I think this is really, really a holy grail that we haven't achieved yet. While we are just doing some kinds of like engineering work. To me, engineering is all about optimization. We are still doing the engineering work to optimize it, to make it more efficient. And also at the same time, I think it depends on what application we are talking about when we talk about scalability. So for example, if you talk about payment, people may say, hey, if you can achieve, say, 40,000 transactions per second, you can take care of most of the retail payment, like Visa card, MasterCard, they are actually at that range. But I kind of agree or disagree, because if you think about digital assets, or if you think about payment in terms of the cryptocurrency, we are talking about the global scale. I'm actually envisioning that in the future, everybody is going to have that crypto, not just those credit card holders can make use of credit card. So the number of transactions per second should be way higher than 40 or 50,000 transaction per second. So how to achieve that while at the same time being decentralized, so that no government or no major authority will be able to simply having a quick kill switch to switch that off. I think that's still a problem, an open problem for us as technologists to solve. So the future is quite exciting, actually. I think even after like this 10 plus years since the beginning of this Bitcoin, we are still at a very early stage. Just like the internet back to the 80s, and we are just maybe at the late 80s. I still have a long way to go.
Yeah, for sure. I mean, if you think about the time it took, everyone talks about what 1, 2, and 3 is, and you go from read to read and write, and now it's owning, right? Owning the assets. And I always question many different things. So these different things are being challenged. Like, do users really care about ownership of their own data because they've been giving it up for so many years? And then, of course, the motivation, if they actually are able to earn from sharing their data, because like let's say advertisement companies are using their person's data, fine, it sounds great. But I always wonder, do people really care? Does it really make a huge difference in their life? Maybe some monetary value, but in the future, I think people are more thinking about what are they going to do with their lives? What's their purpose? What type of jobs that will be out there? I think that technology beyond blockchain and DLT is a bigger. It's actually a bigger question that maybe people don't realize. Because when I talk to people who are not in Web3 or crypto, it's very normal. Life is normal, and maybe they're not looking too much about quantum computer or AI or what the potential impact will be. And I feel like you mentioned, it's still early days, but you look at Bitcoin halving, right? It's happened, like the fourth halving will happen, and it's just happened so fast, and it's grown like in the background, kind of like if you're not in the space, people say, "Oh, Bitcoin, I heard it used to be, at $2 per Bitcoin, and now it's at 25,000." And that was just last year, and now we're at 50,000. So
Yeah.
it just happened so fast that maybe people just don't realize it until it's a little bit too late.
In fact, yeah.
Yeah, go ahead.
Yeah, what I'm thinking is that it's really about the trust issue here. Like people, they are not like, so it's not like people don't care about the privacy or the data ownership of their stuff, but they kind of trust the system. For example, like we kind of trust the banks, kind of trust the legal framework, especially like in Hong Kong. The legal framework is pretty well established, relatively, right? And that's why that kind of trust is there. But that trust, we have to ask ourselves whether that trust is still valid when we talk about digital asset, when we talk about a fully decentralized system. When we talk about a fully decentralized system, do we really think that the system is decentralized when people just say, hey, this is a blockchain system? We actually need to look into those blockchain systems to see whether they are decentralized or not. So I think down the road, trust can be a huge issue. And when that personal information is linked with the digital asset or money, then people would really care about privacy. People will really care about who are going to access my data, who will be able to see how many ABLs of Bitcoin or Ethereum in my wallet. So right now it's all open. It's actually kind of scary. It's very easy to link your name with your wallet addresses, no matter you have just one wallet address or 1,000 wallet addresses. It's very easy to link. So down the road, I really think that the general public would be able to kind of like aware or wake up and see, wow, privacy is really an issue down the road.
Yeah. I think trust is probably like the main theme if you think about decentralization and everything that blockchain is, right? It's supposed to be immutable and people can't change it. And the concept is, of course, there should be more trust. But in your reference to how long it's taken for the internet to actually get to where it is today, going fiber optic and very fast and still in some ways, I still go to websites that are just HTTP and they're not secure. I'm still surprised, right? But then you look at people concerned about viruses. So that was big for a certain period of time until more and more companies came out with these virus software to kind of protect the systems. And I guess, like you said, it just takes a while for the mainstream public to really build trust. It's no different than if you think about credit cards. 50 years ago, people probably didn't trust credit cards, like using payments, and it took a while until they said, oh yeah, credit cards are good because even someone steal my credit card and they spend on it, I call the bank or, whoever, and then they would resolve it. Lots of people, it's very good established systems and people feel safe that even if someone steal my credit card, I should be okay. I'll get my money back, right? So I think you're right. I think that's what it will come down to at the end of the day. Will the systems in place, whether it be used for financial transactions or even verification of people in itself? I was reading. So if you're looking at AI today, and there's this a huge concern about deep fakes, right? So there's a lot of deep fakes out there. Then if you're using blockchain and then you're trying to create computation to compare two different video sets, right? Actually, that's a huge amount of computing power. I don't know. It's quite costly to be able to manage it on scale. It's quite crazy. So, but who knows where it'll go?
Yeah, sadly.
Yeah.
Trust is really the key over here, and I'm just thinking that the trust is going to have some very subtle change down the road. Not going to be far away from now. Maybe gradually, you may not notice, but that kind of trust is maybe losing in the conventional wisdom.
Okay. So I noticed that you said you had your Able coin, right? The Able token. Can you tell me a little bit more about that and, reason behind that, some of the tokenomics? I mean, I guess maybe you can share a little bit about that.
Yeah, so if you look into the ABLE or the we call it native token or Abelian, at this moment there's no different from like BTC on Bitcoin network. So first of all, about the network, Abelian is very similar to Bitcoin network, and then the ABLE is the native token on Abelian. So which means the Abelian is used for paying the gas fee whenever you are sending your ABLEs to from one party to another, from one wallet address to another. So that gas fee is paid to the miners. While at the same time, this ABLE is a digital asset. It's basically a token that you can transfer from one party to another for different kinds of application. That's why we are actually considering this as a conventional digital gold. Gold is a conventional digital gold as of today. While at the same time, as I mentioned, we are building this layer 2. And layer 2 is smart contract enabled, that you can just basically imagine it is EVM equivalent, layer 2. So you can basically just bring your EVM smart contracts from Ethereum or other layer 2 of Ethereum directly to the layer 2 of Abelian, and then you can spin it up and run it. While at the same time, the transaction outputs will be compressed, digest, and then stored on the Abelian network. So again, ABLE is going to be used as the gas fee for developers or for users to run their smart contracts on layer 2. And the third area is that we are building this brick. The Abelian is going to be a quantum resistant, kind of like a layer 0. And then we try to help other chains to upgrade to post-quantum. So for all other chains, when they run the smart contract, and then if they wanted to be quantum resistant or quantum safe, then they will also burn the gas fee, and the gas fee is ABLE. So again, ABLE is mainly the utility token over here. Holding those ABLEs will allow you to run your applications in the future, or just considering ABLE as a digital gold in the future as well.
Okay, thank you for sharing that. All right, so I guess we're at the end of our podcast. I wanted to thank you for your time to join and share sort of like your thoughts as a technologist. To be honest, I actually speak to a lot of like CEOs and business-minded people, and usually the talk is around all the projections of how the product will grow and going after the market and product market fit. But from a technologist point of view, it's always interesting to know like how you see what's possible and the realities of building, because I can imagine it's not easy. I started off as a computer science major right, in school, and it doesn't say much. And I was a developer before and a network engineer, but man, the way that technology has changed, I think it really takes some brain power from a human to figure out these things. Yeah.
Right now we are actually at a very exciting time. A lot of new technologies coming up, and then especially today we are talking about the mixture between blockchain technology as well as AI technology. I think down the road in the coming years, it's going to be even more exciting. So from my perspective as a technologist, I'm really excited. I really hope that I can stay longer in this career and witness all the development and also the convergence of the technology and also the divergence of the technology as well.
From your point of view, I mean, if I were to sum it up, don't be afraid of how technology will change the future. Embrace it and see how we can leverage the technology for a better future.
Exactly. Technology can only make our life easier. And we should actually focus on how to make our life easier by making use of technology.
Perfect. Well said. Well said. All right, Dr. Duncan Wong, thank you for joining the show.
Thank you very much.
All right.
Take care. Cheers.